Hello everyone, welcome back to the GCSE Tutoring YouTube channel. You've got Lucy here with you today, and I'm going to be explaining Pythagoras' theorem. This is a GCSE topic. So, Pythagoras' theorem is an equation which helps us to find the length of a side of a right angle triangle when we already know two sides. So here I've drawn a right angle triangle for you. Now we need to know about the dimensions in our right angle triangle first of all. Of course it has to have a right angle, which I've drawn on for you. And actually that's quite important, that's something people often forget, that's why I've highlighted it. So we can only use this rule on a right angle triangle. And then we have to know about the sides of our right angle triangle. The most important one is our diagonal slanted side there. That has a special name, it's called our hypotenuse. Okay, and that is the side that comes opposite our right angle. So try and remember that hypotenuse because that's going to come in handy. And then we have to label our sides so that we can use Pythagoras' equation. So I like to start off by labelling my hypotenuse C. And then we need to label the other two sides. So I like to label the shorter side A and the longer side B. But it doesn't really matter which way around they go as long as your hypotenuse is labelled as C. That's the important one. And then we can use Pythagoras' equation, which is A squared plus B squared equals C squared. Now that might be an equation you've seen before or it might be a new one. We're going to have a look at some example questions. We're going to start off really basic and get to some more tricky problem solving ones. Okay, so the first example, really basic, is just going to show us how we use this equation, A squared plus B squared equals C squared. I'm going to say it over and over again because it's so important and you really do need to remember it. So, let's first have a go at labelling our sides. Can you remember how we labelled them? We started off with our hypotenuse, which we labelled C. You see how we've got a missing side here, which we're trying to find. And then we label our shorter side A and our slightly longer side B. Okay, and now what we can do is match up these numbers to our equation. So where I've labelled A, this A is going to become that 8 centimetres. So we're just substituting in the numbers. And then where I label B, 14, that's going to become my B in my equation. So 14 squared equals, but we don't know C. C is our unknown, so we're going to leave that as X for now, because that's what we're going to try and solve our equation for. So we've got 8 squared plus 14 squared equals X squared. Okay, let's try and solve that. So 8 squared is 64 plus 14 squared is 196 equals, we still don't know X, so that's X squared. Don't forget those squares, they're really important. Okay, good. So if we add those together, our 64 and our 96, because that's all we can do at the moment, we get 260 equals X squared. Okay, and now hopefully you know how to solve that for X. If we've squared something, we need to do the opposite function to make it the subject. So we're going to undo our squared, which is square root. So X equals the square root of 260. Okay, and that number, you might need to use your calculator for that, is 16.12 to 2 decimal places. And what's our unit? Always remember our units is centimetres to 2 decimal places. I've just put it to 2 decimal places. The question might specify what it needs. Okay, so a little bit of rearranging equations there, but most important is remembering that equation and which way round the labels go. Okay, fantastic. Let's move on to a bit more of a tricky example. So sometimes we get our hypotenuse and we're missing one of the other sides, and this is slightly more complicated just because of how we need to do our rearranging. So let's have a look. Let's put in our equation first. Hopefully you can remember it already. It's a squared plus b squared equals c squared. Okay, and now we need to fill in again. Actually, before we fill in, let's do our labels. So, C is our hypotenuse, A is our shorter side, and B is our longer side, just like we did last time. So, let's start by looking at A. We can see that's the 6 centimetres, so 6 squared, plus B. Now, hang on, this time we don't know B. This time B is our unknown, so we're going to make that one X this time. It doesn't have to be X, could be a different letter, but we quite often use X for unknowns in maths. Equals, and then C, this time we do know, so we can actually fill that one in this time. It's 10 squared. Fantastic. Okay, now the reason this one's a little bit more tricky is just because of the rearranging here. It's a little bit more difficult. So what I would recommend is to do your squares first, so you're working with nice numbers rather than having squares all over the place. So 6 squared, hopefully you know, is 36 plus x squared, because we still don't know that, equals 10 squared, which again, hopefully you know, is 100. See how that's just a little bit more tidy. Okay, now we can do our rearranging. So we want to make the subject of our formula x so that we can solve for x. So we're going to leave our x squared on the left-hand side and try and just boot that 36 over to the other side. So we need to take 36 away from both sides, which leaves us with 100. Take away 36. Okay, now that gives us x squared equals 64, just to solve that. And just like we did last time, to get rid of this squared and leave x on its own, we need to do the opposite function, which is square root of 64, which means x equals 8. Again, let's think about our units. It's going to be centimetres. Excellent. Okay, next page. So now we've got a bit more of a problem solving question. This one's quite tricky. So we've actually got a graph, and you might be thinking, how on earth does Pythagoras relate to this at all? It's not a right angle triangle, but it is. Let's have a look. It wants us to calculate the distance between -4, -1 and 3, 4. I've already drawn on for you where those points are and that distance that we're trying to find. And how might we do that without, of course, measuring? What we can do, if we look across here, let's just draw along and connect up where those lines would meet. Now, hopefully you can see that looks familiar, like a right angle triangle. So actually we can use Pythagoras because we can read these lengths off the graph, and that will help us to find our diagonal length, which hopefully you remember is called our hypotenuse. Okay, so let's start with the bottom length. Let's count along. We've got 1, 2, 3, 4, 5, 6, 7. It's a length of 7. Okay, and up the other side we're going to have 1, 2, 3, 4, 5. That's a length of 5. So we've got our two sides and we've got one missing side, which is what we need to do Pythagoras' equation. So we know that's what we can use here. Okay, so how are we going to do it? As we always do, let's start with our equation, which is a squared plus b squared equals c squared. I told you I'd be saying it a lot. You need to remember it. So now we're going to label our sides like we usually do. A is our shorter side, B is our longer side, and C is our hypotenuse, which is our green side. Now, I'm going to label it C. I'm not going to bother with the